All right, in this video, we're going to quickly discuss some of the details of abstract classes. Let's start out by looking at a UML diagram and show some of the differences that we would see in a UML diagram for an abstract class or an abstract method. First of all, right here, the name of the class is no longer normal. It is now italicized font for geometric object. We have everything else is pretty much the same. If we have an abstract method like getArea, which we talked about in the previous video, we italicize those too. So those are some differences in the UML diagram. Italicize the name of an abstract class, italicize the name of abstract methods. Also, if we look at circle and rectangle, getArea and getPerimeter are overridden in circle and rectangle. But do we see them down here? We don't see getArea listed here as one of the methods in the circle class, and we don't see getArea down here as a method in the rectangle class. However, we know they exist. They have to exist because these two are not abstract. So they are required to implement these abstract methods. So there's no reason to actually repeat them in the UML diagram. Because they inherit from geometric object, they have to have all of these. All right. So things to understand. An abstract method cannot be contained in a non-abstract class. So the minute you try to do an abstract method, your class has to be abstract as well. But the subclass of an abstract superclass doesn't implement all of its methods. And we saw that when I tried to get rid of the getArea in my circle class. I either have to implement it or that subclass also has to be defined as abstract. So if I would have made my circle class abstract, I wouldn't have had to define getArea. But then I couldn't make a circle. I'd have to write another class that inherits from circle, and then I'd have to put it in there. So in other words, a non-abstract subclass extended from an abstract class, all the abstract methods have to be implemented. So this is the rule. All abstract methods have to be implemented, even if they're not used in the subclass, they have to be there, or the class has to be abstract. That's the only way to get around it, is to create another abstract class. And later on, that just passes the responsibility down to other classes that would inherit from that. You cannot instantiate an abstract class using the new operator. We can still define its constructors, which we had constructors for our geometric object class. Those are still used by the subclasses. So we can still have those even though we can't use them along with the new keyword because we can't create an object. We can still use them for inheritance purposes. So that's the example here. The constructors of geometric object were invoked in the circle class and the rectangle class that I showed you. An abstract class without abstract method. So that's how we first started out. I had when I changed the class to abstract, but I had not added the getArea class, that was fine. I don't have to have abstract methods. A class that contains abstract methods must be abstract. However, we can create an abstract class that doesn't have any abstract methods. And that basically just says, hey, you can't create an object from this class, but I'm not requiring that you have anything else if you inherit from this class. Okay, so we can't create an instance of the class using the new operator. It is just a base class for defining a new subclass. If you want to, you can add the abstract methods to enforce methods, but you do not have to do that. You can actually create an abstract class that inherits from a class that was not abstract to begin with, which makes perfect sense because when you think about it, a geometric object inherits from Java's object class. So I guess we're okay there. A subclass can be abstract even if its superclass is concrete, or even if its superclass is not abstract. Another way to say it. For example, the object class is concrete, but its subclass, such as geometric object, can be abstract. There's no problem there. A concrete method. Okay, so somebody writes a class with a concrete method. We can create a subclass of that implements that method, or we can create it as abstract. A subclass can override a method from its superclass and make it abstract. It's very rare. But it's useful when the implementation of the method in the superclass becomes invalid in the subclass. In this case, then the subclass has to also be abstract. You're not going to see this very often, but it is a rule and you should probably know about it. We cannot create an instance from an abstract class using the new operator, but it can be used as a data type. So I can still say, I can still define a circle and assign it to a variable of geometric objects type. So I can still use that type, which is handy because I could make a list of geometric objects, for example. Using that type, geometric object, I can store circles, and I can store rectangles in that list, and I could store triangles in that list, and any other class that inherits from geometric object. So I can't create objects from that class, but I can still use its type to define other things. Here's an array of geometric objects. We could make a list of geometric objects. Its type is still valid. And then let's take a look at this, because this is actually the number class that's built into Java. The number class is an abstract class. And the number class has a, and we know it's abstract looking at the UML diagram because it's in italics. Okay. So it has a byte value, a short value, and then look, we have some italicized int value, long value, float value, and double value. These methods are abstract. So double, float, long, integer, all these classes in Java inherit from the number class, which means because they inherit from this abstract class, and that abstract class has these abstract methods, which means double must have an int value. Double must have a float value. Double must have a double value method. All of these classes must have these 4 methods implemented inside of them. So I'm guaranteed if I have a number that's defined as an integer, I can run int value, long value, float value, or double value on that integer. It's guaranteed to be there because the abstract class number, along with its abstract methods, enforces that rule. All right, that's all we're going to talk about for abstract classes. In the next videos, we're going to start talking about interfaces.